Welcome, everyone. Ready to crack a 100-year-old royal mystery? Today, we're taking our very first steps into the world of squares and cubes. But we're not just going to stare at boring numbers, no way. We're going to learn by solving an incredible puzzle together. So grab your notebooks and let's jump right in. Our story starts with a super wealthy ruler named Queen Ratnamanjari. She had this absolutely massive collection of gold and precious stones. When she wrote her will, she decided to leave all this treasure to her son, Kamaravarma, and 99 of their closest relatives. So, if you do the math, that makes exactly 100 people in total. But there's a catch. She didn't just hand the gold out. She set up a challenge and declared that only the very first person to solve her puzzle gets the entire treasure. Here is the treasure map we'll be following today. We'll cover 1. The Queen's treasure puzzle, 2. How the puzzle works, 3. Solving the big question, 4. The mathematical secret, and finally, 5. Revision and exam questions. Let's kick things off with part 1, the Queen's treasure puzzle setting the stage. Okay, picture this. A massive room inside the royal palace. Lined up along the walls are exactly 100 lockers, numbered beautifully from 1 all the way to 100. And waiting right outside the doors are 100 people. They are also numbered 1 to 100, just waiting for their turn to walk into that room one by one. So moving on to part 2, how the puzzle works, the rules of the game. Before the game begins, there is a really important vocabulary word we need to know for our exams, and that word is toggle. To toggle simply means flipping a locker's door to the exact opposite of what it is right now. If it's open, you close it. If it's closed, you open it. It's literally just like the light switch in your bedroom. Walk in, toggle it on. Walk out, toggle it off. Simple, right? Now, let's see how this game actually plays out step by step. Person number 1 walks into the room and just opens every single locker. Easy enough. Then, person 2 goes in, but they only toggle every second locker. So they are only touching the multiples of 2. Locker 2, 4, 6, 8, and so on. Next, person 3 walks in and toggles every third locker. So multiples of 3, like 3, 6, 9, 12. And this pattern just keeps going. Every single person only touches the lockers that are multiples of their own assigned number. Let's visualize this so it really clicks. Think about those first few lockers. Person 1 opens all of them, right? But then person 2 walks by. Because they only care about multiples of 2, they completely ignore locker 1 and locker 3. But they definitely touch locker 2 and locker 4, toggling them from open to closed. All right, part 3, solving the big question, the investigation. Let's put our detective hats on. So this crazy process keeps going all the way up to person 100, who, following the rules, will only touch locker 100. This leaves us with a huge puzzle. After all 100 people finish taking their turns, what happens? Are all the lockers open? No. Are they all closed? No, only some of them are left open. So the big question we have to figure out to get the treasure is, which of these lockers actually stay open at the very end? Let's break this down and check locker 6. Who exactly touches locker 6? Well, we just need to find the factors of 6. Those are 1, 2, 3, and 6. That means exactly 4 people touch this locker door. Let's trace it. Person 1 opens it, person 2 closes it, person 3 opens it back up, and finally, person 6 closes it. So, it's toggled exactly 4 times and finishes completely closed. Now, let's look at locker 9. What are the factors of 9? Just 1, 3, and 9. That means only 3 people touch it. Let's trace this one. Person 1 opens it, person 3 closes it, and then person 9 comes along and opens it right back up. Because it only has 3 factors, it gets touched exactly 3 times and finishes wide open. Check this out. When we compare these 2 lockers side by side, a massive pattern appears. Locker 6 had 4 factors, which is an even number, so it was touched 4 times and ended up closed. But locker 9 had 3 factors. An odd number was touched 3 times and ended up open. This brings us to part 4, the mathematical secret, the golden rule. Just as a super quick refresher for your exams, remember that a factor is simply a number that divides perfectly into another number without leaving any remainders. And the whole secret to the Queen's puzzle is that the number of times a locker is changed is perfectly equal to the number of factors of that locker number. Okay. Grab your pens because you absolutely need to write this down in your notebooks. This is the most important idea of the entire chapter, the golden rule. It goes like this. If a locker number has an even number of factors, like 6 did, it ends up closed. But if it has an odd number of factors, like 9 did, it ends up open. Seriously, lock this rule into your brain, and you're going to crush this topic on your test. Finally, Part 5, Revision and Exam Questions, Locking Your Knowledge. I highly recommend pausing the explainer right here to test yourself. These are 5 exact practice questions straight from your textbook. 1. What is a factor? 2. What does toggle mean? 3. Write the factors of 8. 4. How many times is locker 10 changed? And 5. Will locker 6 be open or closed at the end, and why? Going through these is the absolute perfect way to prove you've mastered what we learned today. But hold on a second. There is one final piece of the puzzle we need to crack to actually claim the Queen's Gold. If you sit down and do the math for all 100 lockers, the only ones with an odd number of factors are the square numbers, like 1, 4, 1, 16, 25, and so on. So why do only square numbers remain open? What is so incredibly special about a square number that gives it an odd number of factors? Well, to find out how that mathematical magic works, you'll just have to join me for our next lesson.